When we picture pollution, our minds usually go straight to smoggy cities, massive exhaust pipes, or heavy industry, right? We rarely look down at the smartphones in our hands or the laptops on our desks. But the truth is, every single search, every video stream, and every quick swipe relies on this massive, hidden physical infrastructure. We are talking about millions of miles of undersea cables, hyperscale data centers that span hundreds of acres, and the incredibly intensive mining of rare earth minerals required just to build our devices in the first place. So today in this explainer, we're going to make that invisible footprint visible. We're diving into the absolutely crucial concept of making information technology sustainable. Okay, let's get into it. Here is our roadmap for today. First, the hidden digital footprint. Second, decoding climate jargon. Third, the Green IT Rulebook, and finally, the Sustainability Scoreboard.
Part 1. The hidden digital footprint.
So, have you ever actually stopped to consider how much pollution your data generates? Because the cloud, well, it isn't just floating up there in the sky. It's grounded in massive, energy-hungry data centers made of steel and concrete. According to the Global E-Sustainability Initiative, the IT industry is accountable for approximately 2% of worldwide greenhouse gas emissions. 2%! To put that into perspective, that figure rivals the emissions of the entire global aviation sector. And honestly, that's before we even factor in the recent exponential explosion of generative AI. When you combine the massive computational power required for AI processing, the relentless energy demands of crypto mining, and the endless stream of 4K video data being beamed to devices worldwide, that 2% baseline, it's accelerating rapidly. The digital realm has a very real, very physical cost.
So, what's the fix? Well, the core solution to this expanding challenge is sustainable IT. And to be clear, this isn't just a matter of remembering to turn off your monitor at the end of the day. Sustainable IT is the comprehensive practice of minimizing the negative environmental impact of tech while still maximizing its social and economic benefits. It integrates efficiency into the absolute foundation of the tech stack. This means reevaluating exactly how hardware is manufactured and managing its full life cycle so precious metals are actually recovered instead of just dumped in a landfill. It extends to the very architecture of our data centers, prioritizing renewable energy. It even changes how developers work, driving the creation of green code that literally requires fewer processor cycles and less memory to execute the exact same tasks.
Now, I know what you might be thinking. A persistent misconception here is that adopting sustainable IT is prohibitively expensive. But while there are for sure upfront costs associated with upgrading to energy-efficient hardware, green computing fundamentally saves money in the long run. The return on investment is driven by heavily optimized resource allocation. For example, by fully utilizing server virtualization, companies can consolidate their workloads and eliminate what we call zombie servers. These are machines that just sit there idle, doing absolutely no useful work but still drawing massive amounts of power. Plus, there are enormous savings found simply in extending hardware lifespans. Consider a massive enterprise that delays its hardware refresh cycle from 3 years to 5 years. The capital expenditure savings stretch into the millions. It completely changes the financial dynamics of an IT department. So sustainability isn't just good for the planet, it is highly profitable.
All right, moving on to Part 2, decoding climate jargon.
If you've skimmed any corporate press releases lately, you've probably been swimming in a sea of confusing buzzwords. Let's clear those up so we know exactly what these companies are actually promising. The baseline state for corporate climate goals is carbon neutral. When a company claims to be carbon neutral, it means the amount of carbon emissions they release into the atmosphere is perfectly equaled out. They do this by reducing emissions where they easily can and then balancing out the rest by purchasing carbon offsets, like, say, funding a project that plants trees or builds a wind farm. However, it's definitely worth noting that carbon neutrality gets a lot of scrutiny. If a company relies entirely on buying offsets without aggressively reducing their own initial output, critics often view this as simply buying a license to pollute rather than genuinely transforming how they operate.
Now, carbon negative. This is a much more ambitious goal. This means a company is actively extracting more carbon from the atmosphere than it is emitting. In the IT world, reaching this state involves a blend of massive investments in renewable energy and cutting-edge solutions like direct air capture or DAC technologies installed right at the data center level. Some of the biggest tech giants are even applying this retroactively. They're committing to historical footprint reduction. That means they aren't just breaking even for the current year. They are calculating and paying to remove all the carbon their company has ever emitted since its founding day. It's a fundamental shift from just doing less harm to actively repairing the environment.
Then, we have net zero emissions. People very often confuse this with being carbon neutral, but actually, scratch that, it is vastly more complex. Net zero means maintaining a perfect balance between the volume of all greenhouse gases generated and eliminated, not just carbon dioxide, the whole shebang. It's a holistic objective that requires a company to nearly eradicate emissions across its entire supply chain and operations, and this is notoriously difficult to achieve. A tech brand doesn't just have to clean up its own corporate offices, it has to police Tier 3 suppliers deep in its hardware manufacturing chain across the globe. They have to ensure the distant factories refining the silicon and assembling the motherboards are also operating without contributing to greenhouse gas levels.
To put it simply, think of carbon neutral as balancing a scale. You emit some pollution on one side, you pay to offset the equivalent amount on the other side. Carbon negative, on the other hand, is like a giant vacuum. You are actively pulling more pollution out of the atmosphere than you are putting into it. It's a massive conceptual leap in environmental responsibility, moving an organization from a state of equilibrium to a state of active cleanup.
Okay, on to part 3, the Green IT Rulebook.
Achieving these incredibly ambitious corporate goals requires strict frameworks and regulations across the global tech industry. To keep organizations accountable, several global standards act as the ultimate rulebook. We can actually trace a sustainable server's journey right through these standards. It starts with EP, which is a global rating system that guides the initial sustainable procurement of the hardware. The organization purchasing it operates under the ISO 14001 framework, ensuring a strict environmental management system is in place. The server itself utilizes ENERGY Star certified components to guarantee baseline efficiency. And finally, it lives its operational life inside a data center optimized by guidelines from the Green Grid, which is a nonprofit focused entirely on driving energy efficiency in complex computing environments.
But how do companies ensure no emissions are being hidden from these standards? Well, they use the GHG protocol. It's the most widely recognized standard for calculating emissions, and it divides a company's footprint into 3 strict scopes. Scope 1 covers direct emissions from sources the company owns, like the backup diesel generators at a server farm. Scope 2 covers indirect emissions from the electricity they purchase from the grid. But Scope 3 is the real game changer and, frankly, an absolute nightmare for IT companies to track. It covers indirect emissions throughout the entire value chain. Think about it. If a tech giant sells 1 million laptops, Scope 3 means they must accurately account for the coal-powered electricity a user in another country consumes to charge that laptop for the next 5 years. They also have to account for the carbon generated by the cargo ships that transported those laptops. There is absolutely nowhere to hide.
Which brings us to our final section, Part 4, the Sustainability Scoreboard.
If the standards are the rulebook, how do we keep score during the game? First up is a really fascinating metric called Software Carbon Intensity, or SCI. This doesn't measure the total absolute carbon footprint of a company. Instead, it measures the rate of carbon emissions for a specific piece of software, like emissions per minute or per user device. This is a brilliant tool because a rate is a far better metric for developers than just an absolute number. Let's say a new application goes viral. Its total emissions are going to skyrocket simply due to the massive scale, even if the underlying code is highly efficient. SCI rewards base efficiency regardless of user scale, allowing engineers to benchmark every single software update to verify they are writing leaner, greener code over time. When it comes to the physical data centers themselves, there is a theoretical perfect score that everyone chases, and it is 1.0. This is the ultimate benchmark for PUE, or power usage effectiveness. PUE basically measures the ratio of total power consumed by a data center compared to the power actually consumed by just the computing equipment. So a perfect 1.0 means every single watt of electricity going into that building is used directly to run the servers. The reason this is so incredibly difficult to achieve boils down to thermodynamics. Hyperscale computing generates an astronomical amount of heat. Keeping tens of thousands of tightly packed processors from melting requires massive, energy-intensive infrastructure just for the air conditioning and liquid cooling.
To put that into perspective, the global average for standard data centers sits at a PUE of around 1.8. That means for every watt powering a server, nearly another full watt is wasted just on cooling and building infrastructure. However, a Fortune 100 company recently deployed a hyper-efficient data center in Silicon Valley, achieving a staggering PUE of 1.06. Shaving off those decimal points is an absolute engineering marvel. It requires advanced airflow management, AI-driven climate controls, and fully customized hardware. By nearly eliminating IT energy waste, they didn't just drastically reduce their carbon footprint. They are aiming for over $13 million in annual savings on energy expenses.
The financial incentive to perfect this metric is just undeniable.
But wait, true sustainability requires looking beyond just the power grid. We also strictly measure WEU, water usage effectiveness, because data centers get so hot, many of them rely on evaporative cooling systems that consume millions of gallons of fresh water. Tracking WEU has become urgently critical lately, especially with the recent boom in generative AI. Get this. A single intensive training run for a large language model can consume hundreds of thousands of gallons of fresh water just to keep those supercomputers cool. When these facilities are built in regions already facing severe drought and water scarcity, optimizing for WEU becomes just as vital as optimizing for PUE. I mean, you cannot claim you're sustainable if you lower your power bill by draining the local water supply, right?
So, we've explored the massive hidden infrastructure, the strict standards, and the meticulous scoring systems designed to clean up our digital world. But ultimately, technology only scales based on our demand. The next time you stream a video in 4K or send a massive email attachment or prompt an AI model, just take a second to think about the unseen machinery powering your everyday life. What is the true physical, environmental cost of your next click? Keep asking the big questions. We'll see you next time.